screwed up earlier. So you had several things due today, okay? Last night and today. So we're going to kind of spend the day today going over those three things. The chapter 1 and 2 review, then the problems that we did at the end of the chapter. Then with y'all, let me see, this is Thursday, so you guys weren't here. This is Wednesday. Well, this is Thursday. So the last time I saw you was last Thursday. Okay? Did we talk about limiting reactant? I don't think we did. In stoichiometry, I think it was Friday's 6th period that we talked about.
It was the video, though.
It was on the video. I don't think on the video it was about limiting reactant, though. It was excess, doing all that?
Just like a little bit.
A little bit? Okay. So, we're going to practice that and make sure we know how to do that and do some practice problems along those. Now, none of that stoichiometry stuff is going to actually be on the test tomorrow. Okay, only chapter 1, the first half of 2, up to naming. There's no naming on the test. And then the first part of chapter 3, which is percent composition, empirical, and molecular formulas. Okay, that's what's on the test, and these are kind of good practice problems for those. So, does anybody have any questions about any of the definitions on the front side of that review sheet?
Retention factor.
Okay, retention factor. Okay, I was going to highlight that one, so I'm glad you asked. Okay, what does retention factor relate to?
Chromatography.
Chromatography. Okay, so in chromatography, sorry, I had a little bit of an obsession with a clean board to start with. And you guys may not be able to see the marks I'm erasing, but there are definitely marks here. All right, so with chromatography, okay, you have a solvent. You put a piece of paper, chromatography paper, down into that solvent. Nice straight line. Nice straighter. Okay? And then you put some kind of mark that's a mixture of colors on it. Okay, so the key is it's a mixture. It's not just one thing. So, the green, I don't have any ideas what colors in blue, but let's just say the green goes up to here, but there's some red in there too. Red and green make blue, right? They don't, but, okay? But the red goes all the way up to here. Okay? But the solvent goes all the way up to here. Okay? So it's going to be the difference between how far did the solvent travel versus how far did each one of these, you know, this is your starting point. Okay? How far did each of the colors travel up the chromatography paper? So your RF factor, your retention factor, is equal to the distance of the solute. The solute is the green or the red, the part of the mixture, the thing that's going into the solvent, divided by the distance of the solvent. Now, what determines that? Why would red, let's just say that this is a polar solvent. Okay? If this is a polar solvent, which one is more polar, red or green? Red. Because like dissolves like, right? since the solvent is going up and it's polar, the red likes the solvent, so it's going to travel with the solvent. Okay? The green would be more nonpolar. It doesn't like the solvent, so it's going to be more sticking on the paper than it is rising up with the solvent. Okay? Now, it would be the exact reverse if this is nonpolar. The red would be the most nonpolar, and the green would be the most polar. Like dissolves like in solubility. So the key thing in chromatography is that it's based upon differences in what physical property? Polarity. Okay? Whereas distillation, what is distillation? I didn't hear it. Distillation, if you get distilled water, what happens? The difference in boiling points is what distillation is all about. So if you have alcohol, again, the moonshiners, they have alcohol and they have water and all the other junk in there. Well, the alcohol evaporates at a lower or boils at a lower temperature than the water does. So they heat it up, get it right to where, you know, the alcohol is 80 degrees, where the alcohol is boiling, but the water's not. So then mostly alcohol is coming across, then they cool it and recondense it and collect it in their jug. Okay? When you just distill water, the impurities in the water are generally ionic compounds that have high melting and boiling points. So if you just heat it up to 100, those impurities don't boil or evaporate off. Only the water is coming off and all the impurities are staying behind, and then you collect it. So in a nutshell though, distillation is based upon differences in what physical property? Boiling points. So that's what you really kind of know for the questions. Okay? On chromatography is polarity of the solvent. The attraction between the solute and the solvent. How strong of attraction is there? Distillation is based upon the boiling point of the mixture, being able to separate based on different boiling points. Now, here's an oh my fact for you. You guys know oh my means, oh, it's just interesting, but it's not going to be on the test. But when you have alcohol and water, they have enough of an attraction that you can't ever get pure alcohol. That 95% is the best you can make, and the 5% water, just no matter how many times you distill it, you can't separate that out. It's just stuck to it. And when that happens, it's called, fancy word, an azeotrope, A-Z-E-O-T-R-O-P-E, azeotrope. That's an inseparable mixture of two liquids. Alcohol and water form that, okay? Who knows, that might come up in a trivia question sometime. So 190 proof is the strongest alcohol that you can get. You can't get anything more, because proof is always double the percent. So 95% is gonna be 190 proof alcohol. All right. One other thing on that, what is the mass spectrometer measure?
Mass.
Very good, okay. I can tell it's an AP class, okay. A mass spectrometer measures mass. So that seems, you know, ridiculously simple. But again, when there's a multiple choice question dealing with a mass spectrometer, a lot of times they'll say, talk things about oxidation states, it'll talk about orbitals, it'll talk about electrons, it'll talk about some different things. The answer is going to be the one that deals with mass, okay? But I also want us to look at some sample graphs and make sure, and this is on actually in AP Classroom. There you go, click on it. You might come through on it. Oh, I don't want to describe myself. Okay. So, it says the mass spectrum of the element Sb. Does anybody know what the element Sb is?
Lead.
No, Pb is lead. You're close. Okay, did you say what it was? Antimony. Okay? Antimony. It comes from the word stibnite, which is the name of the ore that antimony is found in. Okay? Just that's where the Sb comes from. Again, a little bit more of that useless trivia, things that just stick in my head that I don't know how they got there, but they won't be. Anyway, so antimony is most represented by which of the following? So, if you just have one line on a mass spectrum graph, what does that mean? Okay, there's only one isotope. Its mass number is 122. Its mass is 122. Remember, the mass number and the mass, atomic mass, are very close to being the same. Okay, so we would only have one isotope. So we come over here to antimony, and it says that the atomic mass is 121.76. So how do we calculate average atomic mass? The percent abundance times the mass of each isotope, right? If there's only one isotope, what would be the mass then of the antimony if there's only one isotope? 122. Okay, scroll down to just the B. Okay? So now I have this one, 121 and 123. But do I have equal amounts? If I had equal amounts, what would the average be? 122. But because I have a little bit more 121 than I have 123, where's my average going to be? Closer to 121, but barely. I mean, there's not much difference. So to me, really, this is going to be my answer, because this is going to come out pretty close to 121.7. Right? Go to the next one. Now, I would just look at that and say, okay, that's a potential answer, but always read all your choices. Okay? So if I look at this one, 120, 123, 124, with 124 being the most, where's my average going to be there? It's going to be way over here somewhere, right? Way above the 121.76. And then lastly, okay, over here, obviously, that's going to be way to the 124. Okay, so go back to B, please. So obviously then on this is the one that's going to give you the average. So you have to use the periodic table to know what the answer is supposed to be, and that answer is a weighted average based upon the abundance here. Okay? Now, I need you to go to click, go to 2. Okay? And the question on this one is here, that's super small. But see. Which of the following elements has the mass spectrum represented above? First off, what number, how do we find this? The mass, this is what? What is this measuring?
Different isotopes of whatever element.
And the mass of each one, right? So there's a plethora of possible isotopes here, right? So if I was to kind of get the average of all of these, we have 100 over here, 92. I'm going to put it somewhere in that range. Just guessing. I mean, it's going to be somewhere close to this because there's a lot, but these are going to bring it down some. So what do I look for on the periodic table? Something that has a mass somewhere in the 96, 97 range, right? Now, the common mistake is to go to atomic number on this. This is atomic mass. Mass spectrum measures mass. So we come over here, and the periodic table, although it's arranged by atomic number, the mass is generally increased with atomic number. That's how Mendeleev did the table originally, was by atomic mass. But there were a couple of irregularities, one being between tellurium and iodine. Tellurium is 127.6, iodine is 126.9. But iodine behaves like bromine, and tellurium behaves like selenium. So they were opposite. And then there's another one over here with nickel and cobalt, 58.9, 58.6. Mendeleev was early mid-1800s, okay? Once they found out protons, a guy named Henry Gwyn Jeffreys Moseley, a British scientist, he was able to then determine the atomic number of every element and found that when you put it by atomic number, then these things correct themselves and the trend is perfect. Okay? So the periodic table is arranged by atomic number, but overall, we can look at the atomic mass. So back to this question. That was all just, trivia history of the periodic table. Now, so what do I look for?
Mass number around 96.
Not mass number, of atomic mass, okay, the red number. And so you come over here, niobium is 92.9, molybdenum is 95.94, technetium is 98, and ruthenium is 101.7. So what are my choices over here? I have niobium, which would be 92.9. It's probably not going to be that far down. 92.9 would be right here, the average. Can y'all just kind of ballpark and see that it probably wouldn't be that low? Okay, the next one's molybdenum, which is 96, which is pretty much right in the middle. Then the next one is uranium, which is 238. Okay, but they put that in there because what's the atomic number of uranium? 92. So if you're looking at atomic number 92 versus the atomic mass. And then the last one, californium, okay, it's way over here. Okay, it's element number 98. So again, the last two wrong answers are trying to mess you up using the atomic number rather than the atomic mass. Okay, is everybody good with how to read the graph and what the graph's saying? And this is again, these are AP classroom questions, so these are AP type multiple choice that you could see. One more. Okay? The mass spectrum of a sample of a pure element shown above, based on the data, the peak at 26 AMU represents an isotope of which of these elements? So first off, okay, I'm going to give you a second to think about it. Scroll up and give them the choices. Okay, so notice we have a tall peak at 24, then two small ones at 25 and 26. Pick an answer. Okay, so now shoot me, A is a 1, a B is a 2, a C is a 3, and a D is a 4. What do we think the answer is? Okay? Anybody else? Okay. No.
I can't read it.
You can't read it?
No.
Okay. It says aluminum with 13 neutrons, magnesium with 14 neutrons, iron with 26 neutrons, or titanium with 26 neutrons. Okay? Now, which two can we pretty much throw out right off the bat? The last two. Okay? Because they say 26 neutrons. This is not saying how many neutrons something has. Because what does a mass spectrometer measure? Mass. Right? So, how do I know which one, how do I know it's aluminum or magnesium?
Periodic table.
Periodic table. What's the atomic mass of magnesium? Okay, you need to have one out. 24.30. Okay? What's the atomic mass of aluminum? 26.98, so it's really 27. Okay? So what's the average of this one going to be? Is that 2? Okay, if anybody's in 6th period watching this, I need to give you a periodic table. Obviously I didn't, or I may just not have done it to this particular class. So, which is this, magnesium or aluminum? Magnesium, because we know the average is mainly 24. This is going to bump it up some, but 24.3. Okay, so it's magnesium. Aluminum would be way over here at 27. We good with all that? All right. Any questions at all about the front side of this sheet? Any of the definitions that, some may have been a little confusing. You definitely need to know atomic number, mass number, and atomic mass. You'll have to do problems calculating the average atomic mass, okay? Understanding the mass spectrometer, you do definitely need to understand about chromatography and distillation being ways, physical means of separating, okay? Now, what about the backside? Does anybody have a question on the chart? We're good? Okay? What about the three problems? Maybe? Carrie?
I'm pretty sure they're all right, but D on 19.
Okay, well, why don't we do this? Why don't, there's, what is this, 17, 18, 19, aren't there just three problems?
But they have,
They have different parts? Okay, I know, but let's just do, let's just put them on the board. We can go, yeah, 18, 19, 20. Yeah, switch it up. I'll let Uben do the long and winding road part.
I'll write it back.
I think the PowerPoint just did super basic, just.
Yeah.
Just have
But,
one.
well, you don't mess with that.
I might cut a few questions just so we can get through all the parts.
Well, I'm just saying, you know, for future, when you wanna play that game,
Yeah,
just have the numbers up there and you just click through the numbers,
yeah.
okay?
So I was saying too, like, that's why the PowerPoint, we could use this for tomorrow. So physical tomorrow.
As far as just practice a little bit.
Yeah,
So, what do you have as far as, what down?
so I mean, this is just how basic things here. It's like,
Right.
correct answer.
Yeah, yeah.
These, division, and I have these where it's just.
Now, do you have the correct answer typed in?
Not in the PowerPoint, but I think we have them.
Okay, well,
I corrected
what you can do is put them in the PowerPoint,
Okay.
okay? So just go down here and put in a text box, okay? Put in a new text box.
Yeah.
Okay? And then just put your answer on that, it's 4. Okay, now, you're gonna go over here to, let's see, transitions, that's what you want.
That'd be the transfer of the slide.
Okay, yeah, no, it's gonna be transition right here. So, animation, and you just wanna fade, okay? Yeah, so you can hit that one.
Yep.
So you can hit play. And hit enter, space bar or anything, forward.
Okay, cool.
Okay, so if you do that on each one, so then you click it, you talk about it, then you just click it, it shows the
Yeah.
right answer.
Okay.
Watch the cord. That's Max. Thought I'd given you a shorter one.
Yeah, just take
Okay, so when we're looking at 18, your 10.50 grams per cubic centimeter is what measurement? It's a measurement of what? Okay? Density, okay? I need you to be bold. I'm an old man. You getting all the right answers, but like, oh, I can't always hear. Be confident. Speak it out. I don't ever get in trouble with being heard. I'm always loud. Okay, so that's density, and then 75 cubic centimeters is what, a measure of what unit? Volume. Okay, and density we know to equal what over what? Mass over volume. So density, mass over volume times volume is going to give you mass. Notice cubic centimeters will cancel out. And now she did a good job. You have 4 sig figs times 3 sig figs, so your answer can only have 3. So she rounded to 788. Okay. And then the same thing now, so density is equal to mass over volume, so volume is equal to mass over density. You could do it that way, or you could even set up with units. This is 100% right, okay? I'm just saying an alternate way to think about doing it. You could start with my given. Remember, when you have 2 things that are given, use the one that's only 1 unit on it, not the 2. This is going to be a conversion factor. This is my given. So start with 100 grams, and then you can set up your density as your conversion factor. I know grams needs to go on the bottom, so I say 1 cubic centimeter over 10.50 grams. Now you're doing the exact same thing. 100 divided by 10.5 is just starting with what's given, using dimensional analysis, and using density as a conversion factor rather than doing the algebra D equals M over V. Either one is 100% correct. There's always more than one way to get to the right answer. It's just whichever one makes more sense to you as far as how you want to do it. Okay? All right. Now, let's go zoom in over here on Usman's work. It's in a very faint orange. Okay? So, we have the molar mass. For those of you watching, and you may not be able to see it, hopefully you can zoom in more than this. This is 9 times 12.011, 8 times 1.008, 4 times 15.999. Okay, so it gets the molar mass of 180.16. Okay, now, if I'm looking at sig figs on this one, it won't zoom in anymore.
Yeah, I'll just turn it like
Yeah.
it's funny.
So, when you multiply this out, these numbers are exact. You're going to get probably what, 3 decimal places on that. You're going to have 3 decimal places, still 3 decimal places, still 3 decimal places. So the reality on this is when you add, you go to the same number of decimal places. So technically we could have 1 more sig fig.
No, I think it developed to that exactly, but I just forgot to put a 0.
Well, then if it came out to this exact, then you would need to put the 0 for sig figs. I would not take points off for that. I'm just stressing the rules of different when you have multiplication and multiplication, division combined with addition and subtraction. You do the multiplications first, then when you add, it's all about decimal points. Okay? All right. Again, that's trivial. Don't stress on that. So then he has this many molecules is given. So we have to find a conversion factor with molecules, and we know that that's Avogadro's number. So that gives me moles, and then to go to grams using the molar mass. The molar mass is always conversion, grams to moles. Avogadro's number is always atoms or molecules to moles. Okay, and it comes out to, is that 15,000? Is that what that says?
Yeah, 50,000.
Okay, and just for the record, that every 3 there's supposed to be a comma. And in the textbook, instead of putting commas, because a comma in Europe is like a period, and so the book just uses every 3 they put a space between the numbers. Same thing here, 0.325 divided by the molar mass gets you moles times molecules, goes to molecules. And then this is the part that was messing people up. But in our equation, it's C9H8O4, okay? So in every molecule, how many carbon atoms are there?
9.
9. So there are 9 carbon atoms for every 1 molecule, so you just multiply by 9. Okay? And so, Hampton, what was the issue on this one? Why was this one so challenging? I'm just saying, what was the hard part? You did it right.
It messed me up because I put one too many zeros, and one part I put it right in the calculator.
Yeah.
And so it just messed me up.
But there's just a ton of conversions that you have to do to get to the proper unit, okay? Because you had 50 feet squared as the area, and you needed just the length times width times height, okay? And so he did it all in terms of square feet and cubic feet, okay? Got this many feet, and then he changed it 12 inches in a,
Yeah, that was wrong.
okay? Well, it's set up right, but what should the units be?
It should be inches over feet.
It should be 12 inches over 1 foot. Okay, so feet cancel. And then times 2.54 centimeters over 1 inch. Now, I'm sure that many of y'all did it a different way. Many of y'all may have taken, well, pretty much ounces to grams is all you can do there. But you may have just gone to centimeters cubed here. Okay, and not had to go to feet cubed, because then you ended up bringing, back and forth. But again, there's a lot of different ways you can convert this and do this that are all correct. Okay? So does anybody have any questions about this, doing dimensional analysis? When you're studying for your test, you got chapter 1 and chapter 2 PowerPoints posted. You have the quiz that you took. You have, obviously, any notes that we took in class. We have all the practice problems that we did. Okay, then empirical molecular formula worksheet. All those practice problems. Okay? Once you get that, and then, that's what it's going to be. It's going to be multiple choice, a couple of short answer, and some problems. For you guys here, we'll start the test. You're gonna, you guys will be at home. So class starts at 10 till 2. I'm going to start the actual test at 2 is when I'll post it. And then you'll have till 3:35 to submit it. Okay? So you need to take it during the class period. Hopefully I can just post this one and not post it 6 periods at the same time I post. Because I don't know if you guys noticed that on the quiz that you had a little bit longer time to work on it than the other people. Okay? So little by little I'm working this out. So you have it. All right. So now,